Hey, what's going on, guys? In this video we are going to talk about gates. Particularly we are going to talk about OR and NOT gates. Now let's look at AND and OR gate, and also we are going to see the NOT gate. So when we talk about AND gate, we can write it as A and B, but we don't write this way. We put a dot instead of AND. So when we have a dot B, it represents A and B. For OR gate, A or B can be represented by plus. So A plus B is the NOT gate. Like when we express not OR gate, we put A plus B. NOT gate, we can say not A, and sometimes you will see something like that. A is similar to a prime like this, or you will see A bar on top. So these two are correct way, right? So these are the way to express this AND, OR and NOT gate. Now let's look at the truth table for this one. AND is similar to multiplication. It works similar to multiplication. For example, if we pick up A and B values, A, B, and we are going to see A dot B. Now let's put values 0, 0, 0, 1, 1, 0, and then 1, 1. The truth table works similar to the multiplication. If you multiply 0 times 0, that's going to be 0. 0 times 1, 0. 1 times 0, 0. 1 times 1, 1. It works like multiplication, but it's not actually multiplication, but the pattern comes like multiplication. Now let's look at A plus B. It's also work like that. If you put the same four numbers right here, A, B, and here A plus B, and here we are going to have 0, 0, 0, 1, 1, 0, 1, 1. Okay, so 0 plus 0, that's 0. 0 plus 1, that's 1. 1 plus 0, 1. 1 plus 1, but in binary we don't have 2, so 1, 0, that is 1, right? So it works like addition. And not the truth table for not A is similar to, like when we have A and A bar, it's opposite. Like if we have 0, what is the opposite of 0? That is 1. And if we have 1, what is the opposite of 1? That's 0. So this is the truth table for NOT gate. And let's look at the symbols. So first AND gate. AND gates look like this. So we will have straight line like this, and we have a curve, and this is connected to this one. So if our input is A and B, then A dot B is the output. Now let's look at OR gate. OR gate, we are going to have a curve like this, and then we will have something like this, right? If our input is A and B, then our output will be A plus B. And the NOT gate will look like this. If our input is A, we will have A bar as our output. And this is the basic thing about AND or NOT gate. Now let's explain this AND and OR gate more clearly by some examples. Like let's look at a practical example to explain this one clearly. Okay, let's get rid of this one. Let's say we have, if you want to get an A in an exam, the average should be greater than 93. Average should be greater than 93. Now I'm talking about OR gate, or how does OR works. Okay, average should be greater than 93, or a score of at least 95 on the final exam. Okay, so if you put the truth table for this statement, let's see A, B, and if you want to get an A, that's A plus B. This is OR. A plus B means A or B. Now let's see. if the first statement is false, so we don't have an average that's greater than 93, so that's false. And we don't have a score at least 95 on the final exam. If both of them are not satisfied, then we get false. We don't get an A. And let's see if we get one false, one true. If one of them are true, we will get true because it says or. We have to have average greater than 93 or a score of at least 95 on the final exam. So if someone didn't make this one, but he got a score of 95 on the final exam, he will get an A. And also this is also true. If we get greater than 93 and finally he didn't get the marks required, but he will still get A. And if both of them are satisfied, he will get an A. So this is how the OR works. Now let's look at AND. Now let's see AND. For AND, let's say if you want to get an A, you have to have average that should be greater than 93 and the final exam score. 93 and final exam score. Exam score should be greater than 95. So it has to satisfy both. Now let's put the truth table for this one. So this is AND. So A, B, A dot B. So if two of them are false, it's definitely false, because if two of them are satisfied, 93 and final 95, he will get a fail, like he will not get an A. So let's see if this one is false. He didn't get a 93, average 93, but he got a 95. The final is greater than 95. He got a greater than 95, but he will still not get an A because it has to satisfy both, because it's an AND, right? So it has to satisfy both cases in order to get the, even though this one is true and this one is false, he will not get an A. And if both of them are satisfied, he will get an A. So that's how OR and AND works. And let's talk about chips and AND gates. So in labs, there are three kind of chips you will see. Okay, so first let's say we have a 2-input chip. We will have something like this. So 2-input AND gate, and we will have 4 of them like this, right? 4 of them like this, and one more connected like this. If it is a 3-input AND gate, we will have something like this. We will have 2 like this and 1 like this in this way, and then another one will be connected like this. Okay, so if we have 4-input gate AND gate, we will have something like this. We will have one on top and one in the bottom. Okay, and also it will have legs like this. Okay, so these are some type of chips. Now let's see how to express some OR gate, AND gate, and those kind of things, right? Let's look at an OR gate. Let's say we have A plus B plus C, and we have to have something like this. In order to have this one, we have to have 3 input and something like this. Let's say we don't have that one. We only have 2 input OR gate. How we can make this one, like make this expression using the 2 input OR gate? In order to do that, if you remember math, we can write A plus B plus C. We can, this is also true, like A plus B plus C, we can write this one as this, A plus B plus C. And if we express, or we can say A plus B plus C. So in both ways it's correct. Now let's look at how we can express this one in terms of this OR gate. So here A plus B mean we have A plus B connected to the OR gate, A and B connected to the OR gate, and that one connected to another 2 input OR gate. So when we don't have 3 input OR gate, we can make the same thing with using 2 input OR gates. So here we have C, and this is going to give us the same output, A plus B plus C. Okay, and let's say let's look at some big thing. So let's say we need to have a 4 input OR gate, but we don't have that one, A, B, C, D. So this is A plus B plus C plus D. So instead of this one, if we only have 2 input OR gate, what we can do is we can write this one as A plus B plus C plus D, and let's see how it's going to look like. We are going to have A plus B like this, A plus B like this, and then we will have C plus D like this, and both of them are connected to another 2 input OR gate. So it's going to look like this. So this is going to give the same input. Now what's the advantages and disadvantages? So when we have OR gate, we are going to have some delays. So this is going to be approximately 2 microsecond delay. But if we connect it like this, what's going to happen is it's going to be more delay, because this is 2 microsecond and another 2 microsecond, we are going to have 4 microsecond delay. So if you want to have a faster gate, this is the best one to choose. But if you want to choose a cheaper one, like if you have only 2 gate available, 2 input OR gate available, then this is the best way. So this can be cheaper. Now let's look at another way to have, like, let's get rid of all of this. Okay, so let's say you have a 4 input OR gate and you want to have an expression like this, A plus B plus C, and you want to make this expression in this OR gate. How? This is a 4 input OR gate. Okay, how can we make it? What we can do is we can connect this one to this one and make this one A. In that way we will have just 3. So we supply A to this one, and B, C is going to be like this. Or we can do another thing. We can connect the bottom one to the ground. So this is going to be A, B, and C. The bottom one connected to the ground. In that way we will have this output. Okay, now let's look at AND gate. So you want to get A dot B dot C, and you have a 4 input AND gate. How you can make this one? Same thing, like this one. You connect the bottom one with this one and make this one like this. Or you can, but for this one you cannot connect this one to the ground, because if you in AND gate works differently. If you connect the bottom to the ground, the whole thing is going to be 0. So we cannot do that. What we can do is we can connect a voltage instead of that. So VCC, if we can connect VCC, the 5 voltage, and here we can just input all the other A, B, C. So that's going to give us the same output as this one, and this is the output. Okay, and that's it for this one. Now let's look at a big expression. Let's get rid of all of this. So let's say you want to make an expression, like you want to build this expression on lab. How you can build it? So this is our expression, W bar. Let's write with this one. Okay, you want to build W bar X Y Z bar plus W X bar Y bar Z bar plus W X bar Y Z plus W X Y Z. You want to build this one in lab. Let's see how we can do this. So first of all, we need to have this one. This is NOT gate, and also we have to have other things, right? So we have 4 variables, w, x, y, z. So all of them are going to have circuits. Okay, so we are going to have w bar right here, and then x bar right here, and then we have y bar right here, and also we had to have z, and then z bar. Okay, let's go ahead and make the circuit. So first w, this is w, and we have to have a NOT gate because we have some bars and things. For w we don't have that one, but it's always better to build. W bar, do we have anything? Yeah, first one we have that one, so we definitely need this one. Okay, let's go ahead and continue here. So NOT gate is going to look like this. So this is w, and let's call this one x. Here we are going to have the NOT gate, and let's call this one y. Here we are going to have the NOT gate, and let's call this one z, and here we will have the NOT gate. So since when we have these 4 things together, it means this is AND, right? So we have to have an AND gate in order to connect this one. So let's go ahead and create the AND gates. We need 4 AND gates because we have 4 multiplications. W, x, y, z, that's one multiplication. This one multiplication. So like that we have 4. So we need to have 4 AND gates. So let's go ahead and build that one. 1, 2, 3, and 4. Okay. So let's complete this AND gate. Okay, let's look at the first one. In the first one we have w bar. W bar means this is starting from this NOT gate. So we have to have a line going from here to here. Okay, and then x. It's always better to keep this one separate. Okay, so let's put this one on top like this, and let's go ahead and connect this one. Okay, let's continue. So this is w bar, then x is going to be this one, then after that we are going to have y is this one, and after that we have z prime, that's going to be this one. Okay, so wherever we are starting, we are going to put a point right there to indicate it's connected to this one. Okay, so this is our first one, and the second one, let's use a different color. The second one is we have w x bar. So w is going to go from here, w goes from here, and then x bar, that's going to go from here, and then we have y bar, that's going to go from here, and then we have z bar, that's going to go from here. Okay, so wherever it's touching, we have to put a point. So here we need to have a point, here we need to have a point, here we need to have a point, and we need to have a point. And then the next one, let's use a different color. W x bar y z. W x bar is going to go from here, y is going to go from here, z is going to go from here. Let's find another one. Let's the next one is w x y z. So W is starting from here, X is going from here, Y is going from here, and then Z is going from here, and that's it. Now we have to put points in all the places it's touching. So here we have to have a point. This is a point, this is a point, this is a point, this is a point, and for this one we have a point right here, point right here, point right here, point right here. Okay, now we have created 4 AND gates. Now we have to connect them, all of them, to OR gate, because these 4 are added. This addition means OR gate, right? So we have to combine these 4 to OR gate, and OR gate will look like this. OR gate will look like this. Okay, so we have to connect all of these to OR gate. Okay, let's use this one. OR gate connected to OR gate, and okay, so this is going to be our final output, and let's go ahead and write the terms. Okay, for each of this. This one was W bar X Y Z, W X bar Y bar Z bar, and this is W X bar Y Z, and this is W X Y Z, and this is how we build when we have an expression. So this is how we build a circuit when we have the expression given. I hope this helps. Thanks for watching.